Hello, my name is Val Felipe, and today I'll be teaching you how to evaluate fractional exponents. So before we branch off to fractional exponents, I'll be discussing three key rules to follow when you are dealt with any number or equation with whole number exponents. Alright, so the first key rule to remember is whenever you are dealing with an equation involving two values being multiplied together, all you have to remember is that if the equation has two same bases, for example, x and x, all you'd have to do is take the base right there, and you're just going to rewrite it with 2 plus 5. So you're just going to add both of these exponents together, which is 7. So x to the second power times x to the fifth power is equal to x to the seventh power. The second rule is that whenever you have an equation involving parentheses, like x to the second power parentheses to the third power, you would grab that base right here, and all you would do is multiply these two numbers right here, 2 and 3, which is 6. So x to the square, x to the second power, parentheses to the third power is x to the sixth power. And lastly, whenever you are given a problem with a negative whole number, like x to the negative eighth power, you have to remember that to rewrite this, it's gonna have like a fraction form. So we have 1 as a numerator, and then we just take this whole piece and kind of like shove that into the denominator without the negative symbol on the eighth power. So it'd be 1 over x to the eighth power. And if you're given a question like rewrite 1 over x to the eighth power, you would flip-flop and bring this up and pretty much kind of like grab this part, rewrite it, and just stick a negative right there on the exponent. So those are the three key rules to follow whenever you are dealing with equations involving whole number exponents. So now we'll be talking about any value or equation with a fractional exponent. So first of all, you might be asking to yourself, what is a fractional exponent? So it's pretty much a number with an exponent as a fraction. So we're going to be solving these kind of questions with a special type of equation. So for example, we have x, and then we have a over b as the fractional exponent right here, a over b. So in order for us to solve this, we would convert it with a square root symbol. So we keep the base and plug it right here, and then we grab the denominator, which is going to be the root, and we grab the numerator, and we shove that right here, so it'd be x to the a power. So pretty much what you convert is you're converting from a fractional exponent to a root of a variable with a power on it. So it's pretty much so this right here is saying it's the bth root of x raised to the a, if that makes any sense. So now that we have this settled, we're going to be going over 3 examples where this would apply to, and we'll be solving from there. All right, so our first question is 4 with the exponent 1 over 2. So pretty much all we're doing is correlating this sequence right here with any problem given. So for example, the x is representing the 4, and then this fractional exponent is representing this exponent with 2 parts, a and b, a and b. So a is 1, and then b is 2. So pretty much all we're going to do is convert this fractional exponent, starting with, we're going to be having to add a radical symbol. And then whatever the x value is, which is 4 in this case, will be put right here. And then the square root, or the root that replaced b, is anything that's in the denominator. So that's a 2, which will go right here. And then we technically don't have to add the 1 here, the a value right here, because 4 to the 1 is already 4. So right now that we're with this, it's pretty much asking what is the square root of 4. So pretty much it's asking us what 2 values equal 4. So in this case, it'd be 2 times 2, because these two values equal 4. So that pretty much just means that this right here is equal to 2, because the square root of 4 is 2, if that makes sense. Because you're pretty much just trying to find two of the same numbers that equal this value right here. So like, for instance, we're given 2 to the 16. I'm going to give you a few seconds to think about that. So what two numbers that are the same that would give you 16? Or the two same numbers you would multiply together, which will give you 16. So that would be 4 times 4, right? They're the two same numbers, and both of these multiply to 16. So this would be 4. So let's go ahead and talk about this right here. So we have 125 to the 1/3 power. So we're pretty much relating this with this. So we have 4 is in, or 125 is in replace of 4, and then 1/3 is A and B. So we're going to go ahead and rewrite this right here with a radical symbol. And then with the patterns already given, you're going to add the 125, put the 125 right here. And then this 3 right there. And then 1, we technically don't have to put it. So now we have a 3 given the rewrite. So this would pretty much be what is the cube root. So just like the 2, instead of 2 values that are the same, we're going to find 3 values. So 3 numbers that multiply together that equal 125. So like, it'd be 5 times 5 times 5, right? Because there are 3 values, all the values are the same, 5, 5, and 5, and they multiply to 125. So this just means that the cube root of 125 is 5. So now that we've covered easier questions, pretty much, we're going to be going and discussing over like challenging questions. So I'm going to go ahead and take this example right here, 125 to the 1/3 power, and we're going to go ahead and rewrite this. Rewrite it right here. So after all the math we did earlier, we already know that the answer to this is 5. So what if we were given a question, what is 125 to the 2/3 power? So to think about this, we would go ahead and rewrite it with 125, and then pretty much this right here, 2/3, the denominator is 3, right? And we already know that to get to 2/3, you would do 1/3 times 2, right? So we go ahead and put this 1/3, parentheses, and then 2. Since we already know 125 to the power of 1/3 to the power of 2, if you just multiply these two numbers, it gets you back to 2/3, right? So given this, we already know what this inside is, because we already said it equaled 5, right? So we're going to go ahead and, let me go ahead and rewrite this right here. 125 to the 1/3 to the 2nd power. We're going to go ahead and just solve this. So we already know this is 5. And we'll go ahead and drop down to parentheses. And then this to the 2nd power. So what is 5 to the power of 2? 5 times 5 is 25. So this just means that 125 to the power of 2/3 is equal to 25. And yeah, so you can already see there's a difference. There's a major difference between having two different fractional exponents. So pretty much anything with a higher value than 1/3. So for example, let's say 125 to the power of 4/5. We can simply rewrite it as 125 to the 1/5 power, parentheses 4, because we're pretty much taking these two values and multiply them together is this. So that's our second problem, and we'll be going over our last problem right now. Alright, so our last and final challenging question will be parentheses 4/9 exponent 1 negative 1/2. So whenever you're dealt with a negative fractional exponent, the only way to pretty much get rid of that negative symbol is to flip-flop the numerator and denominator. So doing so, we would rewrite this problem as 9 over 4 to the power 1/2, like so. So now that we've made it with this far and there's no negatives anywhere, we pretty much have to apply this with this equation we talked about earlier. So given this, the x is pretty much representing the 9 over 4, the AB is representing the 1 over 2. So we're going to go ahead and convert this problem with a radical symbol. So the x value in this case is 9 over 4. The b value, which is the denominator, is the square root, or the 2, and then 1. We don't have to put 1 because 9 over 4 to the 1 is it's 9 over 4, right? So now this may look familiar, right? Any problem with a square root means you need two values, two of the same values that multiply to a number. For instance, let's say we have 9, right? So what two of the same values give us 9? I'll give you a second to think about it. What two same values multiply together equal 9? So, which is 3. And do the same thing with the 4. Two numbers of the same value that equal 4. Or two values that multiply equal 4, right? So in this instance, 2. And that's it right there. So the answer would be 3 over 2. So 4 over 9 to the negative 1/2 is equal to 3 over 2. So I hope you understand pretty much the common core of evaluating fractional exponents. And all it is pretty much remembering x over x to the x with exponent a/b, and converting it to this form right here with the radical symbol. And just remembering these core rules with whole number exponents, because they can easily be referred back to fractional exponents. Like, let's say we have a negative 1 over x to the negative 8th. As you can remember, we went ahead and in one of these problems, like right here, we flip-flopped to get rid of the negative. And yeah, it's just remembering the 3 rules with the whole numbers and kind of getting this down right here. This is pretty much the key part right here in this section. But yeah, hope you enjoyed. Hope that was thorough, and hope you enjoyed and kind of like learned something from this. I know I did making this video. So yeah, I hope you enjoyed again, and thank you for tuning in.